Okay, so for this question, it's a modelling question and it's using exponential functions. And we can see that it's an exponential because we have this power of minus t, or essentially minus x. So if that's as a power, then that tells you that it's an exponential function. So for the first question, we're finding the population at the start of the season. So that word start, that tells us that it's from the beginning, or initial sometimes you see, and it's where essentially t is equal to 0. So it's right at the start. So all I'm doing there is substituting in when t is equal to 0, and then that will give me my final answer. So when t is equal to 0, I have, if I just rewrite this, P, the population, is equal to 1,350 plus 400 times 1.25 to the power of 0. And if I type that into my GDC of 1,750. And then for the second part, this is after 5 days. So this is where t is equal to 5. But other than that, it's the same thing. So I'm doing P is equal to 1,350 plus 400 times 1.25 to the power of 5, because it's after 5 days. And when I do that on the calculator, I find I get 1,481. So for the next part, it's the time taken to decrease the population so that it goes below 1,400. So for this one, I'm going to want to use the GDC, and I'm going to type into here my graphing model, so 1,350 plus 400 times 1.25, and that's all to the power of negative x. Whoops, so that should be, there we go. And I want to know when is that equal essentially to 1,400. So I'm plotting that as my second function. And when I graph this, the blue line there is my model of the population. And then this is my 1,400. And I want to know the first time it drops below that. So to find that out, I do calculations. I can do my intersection. And then I'm finding the intersection between those 2 points, which is 9.31. So 9.318. So rounded, that would be after around 9.32 to 3 significant figures days. And then for part C, I want to find the smallest possible population of the birds. So if I think of my graph, at the moment we have this. Essentially, we're being asked for the asymptote. We're being asked for what value is it getting very close to, and what point is it leveling out. So eventually, when I go on forever, what will the value of the bird's population be? So to find that, I can go to the table of values. Now it's the blue graph there that I'm interested in. And we can see as we increase our value of x, it's 1,350. So it's 1,350 that I'm aiming towards. So that would be the long-term population. And it's basically just the asymptote. So P is equal to 1,350.